So, achieving wonders with query store. This is our first subject today. Uh, for whom missed the introduction, my name is Dennis Torres. I'm a data platform MVP with some Microsoft certifications. I'm also the leader of the Malta Data Platform User Group, and you can see my contacts. It will be a pleasure to stay in touch. Maybe you saw some announcements with a different speaker on this first session. The speaker, Depsy, had a family emergency, and so I'm replacing her on this first session about Query Store. Not exactly replacing her, but we expect to have her for another session later, probably in the beginning of next year. So, our agenda today, why do we need Query Store? The main questions that Query Store help us to answer, what Query Store does. Writing architecture, reading architecture of data, the schema used for Query Store, and some details about configuration. So, why do we need Query Store? First, it's important to remind that we are talking about the technology Query Store, which was introduced in SQL Server 2016. Why are we starting with a let's say, so old technology introduced in SQL Server 2016 when the subject today is SQL Server 2022? Because Query Store is the foundation for new technologies. A lot of the new technologies that other speakers will explain to you during the day, they are based on Query Store. That's why we're starting with Query Store, with the technology that was introduced in SQL Server 2016. So, usual problems that we have in production or we had before Query Store. Like the user coming to us and saying, the queries are becoming slower and we don't know why. Why are the queries becoming slower? The queries are sometimes slower and sometimes faster, and we can't identify exactly when this happens. If I change one configuration, for example, if the user change one configuration, how would this affect the queries in the server? These are usual problems, and these problems were very difficult to solve. These were questions very difficult to answer before Query Store. Before Query Store, these were questions very difficult to answer. So, what happens with Query Store after we got Query Store? And the main question, just summarizing all the others, what has changed? Sorry. What has changed on the environment? What has changed on the environment that caused a problem? That made the queries be slower and caused some trouble on the environment. This is the kind of question that Query Store help us to solve, help us to answer. So Query Store to the rescue. What Query Store does, it keeps a record of every executed query. Query Store keeps a history of what we are executing on our servers. Keep a record of each different plan for every query. So it's not about only about the query itself, but it's about the plan for the query. So if your query is recompiled, Query Store will know that query is receiving a new plan, and this will be recorded in Query Store history. Summarize execution statistics for each query plan. Of course, we can't have a precise value for each query execution, but query store summarize the information about execution statistics for each query plan. According our configuration, we can configure query store to get a summary every 15 minutes, every 5 minutes. This information is configurable. We can configure this on the settings of query store. And the basics, how query store works. Query store can be enabled or disabled on each database. So query store works by database, and we can enable or disable query store on each database. Let me give you a spoiler. On SQL Server 2022 is the first SQL Server version where query store comes enabled by default. On our previous versions, query store were disabled by default. On SQL Server 2022, query store is enabled by default. Information is stored in the database. So all this information, all this history captured by query store is stored inside the database. And what's the result? We have a history of queries and query plans and a statistics of their execution. So if a query plan changes the execution statistics, for example, if a query plan for some reason gets worse, the query store history is able to identify it. We can see that a query for some reason became worse. The famous complaints from our users, oh, our query are becoming slower and we don't know why. We can see this information on query store history. Before SQL Server 2016, it was very difficult to answer questions like this. Sometimes we had to create our own custom history methods to keep a history of what was happening on the server. Now Query Store provides this for us. And this problem even got a name. Query Store was capable to identify this problem, and this problem got a name. We call this problem as query plan regression. This means when a query is recompiled, a query gets a new query plan, and the new query plan for that query is worse than the old query plan. This is what we call query plan regression. So we got a name for this query store, the typical problem that query store can identify. So another query, how do we solve this? Of course, this needs a deeper investigation. Why the query plan regressed? Why the query was compiled with a new query plan which is worse than the previous one? So this needs further investigation. This requires further investigation. But there is an easy way to solve the problem using query store. Another query plan can be easily forced. We can say to query store, please force this query plan in your history. So query store is capable to force a query plan. And every time that query is executed, instead of being compiled and executed with a new query plan, it will use the forced query plan from query store. So the typical question, what has changed? So query store can be great for upgrades or other important configuration change. Imagine that you are making an upgrade from a SQL Server version. You are upgrading SQL Server version from 2016 to 2017 or 2019, and you want to be sure that everything will be better and not worse. You will not have any of your queries getting worse. So you can use Query Store to identify these problems. So how we can identify these problems? For example, we can migrate the version keeping the old compatibility level. We keep Query Store enabled for some time with the old compatibility level. For example, we migrate from SQL Server 2016 to 2017, keeping the old compatibility level and keeping Query Store enabled for some time. Then we change the compatibility level. What will happen? If for some reason any query plan regress, if any query is compiled with a query plan that becomes worse, Query Store will be capable to advise us, will be capable to show this information to us, and will be able to identify this problem, which is called query plan regression. So, keep instability during an upgrade from 2016 or 2017, for example. Upgrade the server version, but keep the old compatibility model, turn on Query Store, creating a baseline. Query Store is absolutely great to create a baseline for the execution of our server. Then we change the compatibility level and check the results and fix any possible regression pointed by Query Store by forcing the old query plans. We can force the old query plans and in this way fix any possible regression. So, writing architecture, what do I mean about writing architecture? I'm saying that query store is enabled by database on the database level, and query store writes data to the database. And how is this architecture of writing data to the database? So, query store captures the data in memory to minimize the I/O overhead. And the moment Crystal saves data to the disk is asynchronous. It saves to internal data tables to the disk in an asynchronous way. So when a query arrives to the server, the query is compiled. Then during the compilation, the query test and query plan are saved, initially in memory and then asynchronously saved to the disk. Then we have the execution. The execution captures the execution statistics, runtime statistics, and once again, this information is captured in memory and in regular intervals which are configurable. We can configure these intervals. We save the information in internal tables inside the database. And the reading architecture, how can we access this information? Query Store use DMVs, which allow us to access this information. DMVs allow us to access this data, and they in fact merge the data between what is saved and what is in memory. So this results in the query store views. We can get all this data from saved and in memory to us. And what's the schema of these views? How can we access these views? What's the schema used for these views? So we have one view containing the query store text, the text for a query, and one view containing context settings for a query. A query itself involves the text of not only the text of the query, but the context settings. The same query with different context settings is considered a different query. So a query involves both the query text and the context settings. Then, each query can have multiple query plans. The same query can be compiled many times in the server and receive multiple query plans. Query store allows us to identify these. We identify that the same query received different query plans along the history of that query. So we can identify the query plans. Sorry. And then we have the runtime statistics. For each query plan, we collect the runtime statistics on a specific interval. These intervals are predefined. 5 minutes, 15 minutes. What's the interval of the runtime statistics? So query store has also a DMV that sets the timing of these intervals, uh, specifying the time of the collection of the runtime statistics. And for each interval, we have a runtime statistics for each plan execution that was executed during that interval. So these are the DMVs that we have to get the information about our queries. So the query view brings us one line per query. Then the plan view gives us one line per plan for each query. And the runtime statistics, one line per plan according to the interval we define. 5 minutes, 15 minutes, what we choose. These are initially internal tables, and then we have DMVs to access this information. Query store query text, query store context settings, query store query, plan, runtime stats interval, and query store runtime stats. So these are the supposed DMVs for query store. And SQL Server brings some predefined graphics to allow us to view the information, compare different plans, analyze the executions, and so on. So we can monitor the query store performance using these graphics. Are we limited to these graphics? Of course not. We can query directly the DMVs of query store and get the information directly from query store, not a problem. We are not limited to these graphics that are brought for us by query store, but they are a very good starting point. So let's see a demonstration about all these that I just mentioned. So use master. I use a database called Query Store Demo. Let me be sure that my tool to make zooms is enabled. So we have here a database Query Store Demo, but in fact, I'll drop this database and create it again. So drop database and create it again and create it again, enabling query store. You can see query store demo database query store enable, and I'm enabling a very low interval, 1 minute. You need to be careful in relation to these intervals. If you set a very low interval, you may have some level of overhead or on the database. So this is an important configuration. The interval of collection of runtime statistics for query store. If the interval is very low, you may have some level of overhead. If the interval is very high, you may not collect precise statistics about what's happening in your environment. So I just executed this. Let's use the database query store demonstration. I'll create a table, DB store. This table has 3 fields, C1, C2, and C3. 3 fields in this table. Okay, sorry. I thought I had executed drop database if it exists, but it seems I didn't. So be sure that I dropped everything. So I'm using the query store demo, creating the table, DB store, 3 fields, C1, C2, C3. Okay, and I'm creating a store procedure. This store procedure will filter the content of the table, DB store, and filtering by the field C3. It's receiving a parameter and filtering the content by the field C3. Okay, execute. That's it. So now I'll insert some data into these tables, filling the fields C1, C2, C3. And you can see a different amount of rows that I'm inserting. For example, rows with value 0, I'm inserting only 10 rows with value 0 on C3. I'm inserting 20,000 rows with value 2, and so on. So what this means? This means that this data is skewed. Uh, the distribution of the values on the table are very different. And this caused a problem that we later call parameter sniffing. Why? Because depending on the value that you use to make a query, for example, 0 or 2, the best query plan would be different. We would have a difference on the best query plan for each situation. So let me execute the insert of this data inside query store. Okay. Be sure that query store is on. And now I will execute the first stop procedure. The stop procedure I created using the parameter 0. The parameter 0 is the one which has only 10 records. Has only 10 records with the parameter 0. Let's include the actual execution plan. So I'm selecting that to include the actual execution plan. And let's see the result. Okay, so the actual execution plan at the moment is a table scan. Yes, it's a table scan. It's a table scan because I don't have any index on this table. I don't have any index on this table, so I'm using a table scan. And here on our database with query.enable, we can see many predefined dashboards that QueryStore provides to us to show how the queries are performing on this database. So we have these many predefined graphics for that. Let's check the top resource consuming queries. It's my query. This is my query. Select C1, C2 from the B store where C3 equal and the parameter, and the plan is a table scan. We have the plan one here as a table scan. Okay. Let me close. Now I'll create an index. Create an index. And execute the same query again. Using the index, I got a new query plan. So the same query got a new query plan. Now the query is using an index seek and it's using a row ID lookup. Well, I have only 10 records with value 0. For only 10 records, it works to use a row ID lookup. No problem with that. It was the trouble. Okay. Let's check again the top resource consuming queries, and we can see the second plan here and the first plan. So we can see both plans. It's by total duration. Let's check CPU time, and we see the second plan using the index seek used way less CPU time than the first plan. So there was way less CPU time used for the second plan than the first plan. And it's showing me the current plan this query is using. This query at the moment is using the second plan. I can select both plans and select the option to compare these plans. Compare plans. When I select this option to compare plans, it gives me all these user interface comparing two different plans for a query. Of course, these plans are very obvious. It's obvious the reason why the plans are different. But in way more complex plans, this compare plan may be very useful because it highlights the operations that are different on both plans. And once I get the same operation, for example, the select operation, it highlights in the property windows the difference on the values. How the values are different from one plan to another plan. So it's highlighting the difference of values between the plans. Okay. So I just did a compare between the two different plans, one using an index, the other not using an index. Let's see what happens if I drop the index. I drop the index, let me clear the cache, and try to execute the query again. So since the index was dropped, I got the table scan plan again. The tables complain again, returned. What happens with the query. So we can see that SQL Server would like to use the plan 2, but the current plan is the plan 1, especially because I dropped the index. So it started with plan 1, I created an index, it moved to plan 2, but since I dropped the index, it moved back to plan 1. It's executing plan 1 again. Okay. Let's ignore for a moment that I dropped the index. Let's try to identify what's the cause of the problem. Why this query plan regressed? This is an example of query plan regression. Why this query plan regressed? So we have a DMV called sysdmdb turning recommendations. In fact, this is not from SQL Server 2016. This is from SQL Server 2017. CSDMDB turning recommendations. So let me execute this query, and we have a turning recommendation. SQL Server, based on the information query store, is recommending us to force the less good plan. You should force the less good plan based on the performance of the plan. So the turning recommendation is giving us this recommendation. This turning recommendation has some JSON fields, especially the state JSON fields, and the details JSON fields. We can extract additional information from these fields. Let's start from the state JSON field. We need to use the OpenJSON to extract information from these JSON fields. So let me use OpenJSON, and here I'm extracting the information from inside the JSON field. And what is it showing? It's showing that the turning recommendation is on, is being displayed and considered active because automatic turning option is not enabled. Automatic turning is not enabled, so it's giving us this turning recommendation. Automatic turning. Does this mean SQL Server could fix this automatically for us? Yes, this means SQL Server could fix this automatically for us. SQL Server is capable to fix this automatically for us. How SQL Server can fix this automatically for us? Well, if we enable automatic turning, SQL Server would immediately apply the plan forcing. When a turning recommendation like this appears, SQL Server would immediately apply the plan forcing. It's not so easy because the automatic turning has some restrictions. A query needs to have a problem that is on the level of many minutes. If I'm not mistaken, and if it has not changed across the versions, it's 10 minutes. A query needs to be 10 minutes worse than the previous plan for the automatic turning takes place. So it's not something easy to illustrate. But it's possible, but not something easy to illustrate. And let's check the other field, like let's check the field details here. On the field details, let's execute. So what's interesting inside this field details is that the recommendation was to fork the plan. And it's giving us the command that we need to use to force the plan. Inside the query store recommendation, it's giving us the exactly script that we need to use to force the plan. It's inside the recommendation. So it's already there. This is already there. Here I'm before forcing this plan, I'm creating an event, extended event session. If you are not using extended event yet, you should. You should. Because SQL Server Profiler is deprecated, and the power of extended events is capable to show us lots and lots of information that SQL Server Profiler is not capable to show to us. Lots and lots of additional information. Ellen just made a joke a few days ago how SQL Server Profiler is close to turn to 25 years old. The SQL Server Profiler. In some countries, it's getting to the age to drive. Other countries, it's already on the age to drive, but in some countries, it's getting to the age to drive right now. I already have the session created here, extended event session. This session is intended to show us problems with forced plans. Here we can see the session. And I'm capturing the event query store plan forcing failed. So this session is intended to show us problems with plan forcing. So I can watch live data. Of course, in a real production environment, I will not be watching live data. In a real production environment, I will configure extended events to save this data to a disk. And this is possible even in Azure SQL Database. You can save extended events data to a blob storage. This is usual for an Azure SQL database, so no limitation on this. The watch live data is something that we use for live demonstrations like this one. So I force the plan. I'm pointing to query 1 and forcing the plan 2 of query 1 using the SP query store force plan. So I'm forcing one of the plans. Let's see how the graphic appears. See, we have one plan forced. So one of the plans is forced here. Okay. Then I can identify the forced plans by querying some DMV query store plan, link it to query store query, and check if the plan is forced. This is an interesting monitoring query for the DBA to check if the query store on the database he is working has any forced plan. So I can identify that we have a forced plan. We have a forced plan for one of the queries in query store. Then now that I have a forced plan, let's execute this query again 20 times. Let's see the execution and surprise, surprise, our forced plan is not being executed. The reason is obvious. I dropped the index. It can't be executed because I dropped the index. Obvious. Why it can't be executed? So it's still using the old plan. Okay. What happens on the extended events? On the extended events, we can see the event query store plan forcing failed. See, you have a new event to monitor on extended events. As a DBA, you should be monitoring this event. Query store plan forcing failed. So, if for some reason a plan is forced, but that forced plan can't be executed, this event will be happening. If this event is happening in your environment, you need to be aware and you need to fix the problem. And you need to fix the problem with this event. Okay. And here it's explained why the plan is failing. There is an additional message here. The index which is needed for the plan does not exist anymore. The index was dropped. That's why the plan is failing, because the index was dropped. So we can check the state JSON again to see the current status of the recommendation from SysDMDB turning recommendations. We can see the current state of the recommendations. And we have here the recommendation, current states of the recommendation is considered a success because a plan was forced by a user. So the recommendation was fulfilled, but the plan forcing is failing. So if we check more details about the plan forcing, we can see a field here called less force failure region description. No index. This plan forcing is failing because there is a missing index in the database. This index is not there. That's why this plan forcing is failing. Let's create the index again. Also create the index again. And I execute the query. Now it's using the index seek and row ID lookup again. We can take a look on the graphic. So see, it's using the forced plan again. One more time, it's using the forced plan. Okay. And we can again check how is the status of the forced plan. One interesting point is that the less force failure region desk doesn't change, is not updated because the plan is now working. The plan failed before. This field continues with the last failure region. It's not telling us that the plan is failing now. It's telling us the last time this plan failed, it was because there was no index, but it's not telling that the plan is failing now. So we need to be careful with this information. We need to take very care, be very careful in relation to this information. Okay. So we have sorry. We have another example here, plain regression. Okay, that's it. This is the main demonstration illustrating this failure on the plan. In fact, I was using this demonstration query store. No, I was using the main script. Okay. Let's make a different demonstration now. We saw about the plan forcing. I can unforce the plan at any moment. Unforce plan. I can do this with store procedures, or I can do this visually, unforcing the plan. So I'm unforcing the plan. And one detail that I mentioned before is about the data that I inserted on this table. The data is skewed. So the value 0, for example, has 10 records, but the value 2 has 20,000 records. So the value is a bit skewed. What happens if I execute the procedure sometimes with one value, sometimes with another value, and so on? What happens in a situation like this? The result is a bit expected. It's what we call parameter sniffing. The first execution, the first parameter used for the execution sets the plan that will be used. The plan that will be used is the plan for the parameter 0. Then the parameter 2 will end up using the same plan as the parameter 0, and so on. So we see the plan 2, which is the plan using an indexing and a row ID lookup. Let me show the CPU time execution. So what we see on the plan on the parameter 2, we see a very different consumption. Sometimes this plan consumes a very low amount of CPU, and sometimes this plan consumes an extremely high amount of CPU. This illustrates the problem which we call parameter sniffing. This is illustrating a parameter sniffing problem. So I built a query, a function to identify queries with parameter sniffing problems. I'm using the query store DMVs. I'm using the query store DMVs to check the history of the execution and analyze queries with a big, very big standard deviation. In fact, we can see this in the total as well. Standard deviation. We can see queries that have a very high standard deviation of CPU time. This query has. At the moment, this query has a very high standard deviation of CPU time. It means that the value of CPU time consumption varies a lot. It's varying a lot. Okay, so I can use this query to get the results in order by standard deviation. The query with the biggest standard deviation You see the standard deviation value for duration and CPU time here. And the query with the biggest standard deviation is exactly my query, which is suffering of parameter sniffing. Is suffering with parameter sniffing. So the traditional solution for this, and now on this session, I'm showing the traditional solution for this. On the other sessions during this day, you see very advanced solutions for this and how SQL Server can treat this in way better way. But the traditional solution for this is to use an option recompile. We could apply an option recompile on the stop procedure level. Yes, we could apply the option recompile on the stop procedure level. But I'm not doing on the stop procedure level, I'm doing on the query level. That's it. So the option recompile display on the query level. So let me clear the cache. Completely clean the cache to be sure that the correct plan will be chosen. Let's execute this again. Okay. Let's check the execution plans. What we will see here is that on some queries, for the value 0, it uses the index 6. But if I go down and see the queries for the value, what was the other value? Was value 2. It used the table scan. So the query is not attached anymore to a single plan because this query is being recompiled to identify the best plan for each moment of the query. I can use my function again to identify query with parameterization problems. This function breaks down the result by plan ID. So we are seeing a plan ID with 2 and a plan ID with 4. And you see here the values. You can see how the standard deviation of CPU consumption reduced a lot. Reduced a lot. You have 1 digit less on the main value. And the standard deviation for duration also reduced. You also have 1 digit less for the duration. So we still have some standard deviation, but there is a huge reduction on this, showing that this query is not suffering from parameter sniffing anymore. What is the exactly value of standard deviation that would show us that a query is suffering from parameter sniffing or a query is not suffering from parameter sniffing? There is not a precise rule. There is not a precise rule for that. No precise rule. So we need to discover, according our environment, what values we need to consider in danger, that query is in danger, that query is suffering from parameter sniffing or No, this other query is not suffering from parameter sniffing. So since Query Store, since SQL Server 2016, we became capable to identify the queries suffering from parameter sniffing, as this example illustrates to you. And we are talking about technologies which were created in SQL Server 2016. Now, on SQL Server 2022, there are way more advanced technologies, and that's what you see on the further sessions. Before finishing, let me illustrate some additional details. Give me a second to get one example for you. Uh, the query store leaves its data in table, DMVs inside SQL Server. We can get this data and build dashboards to analyze the data from query store. This example is the Power BI template, which can show us some dashboards to analyze the query store data. Let's wait some moments. I hope it's opening Power BI. Now it opened a lot. I don't really need to sign in at the moment. It's a template. So once I connect, it asks me about what database I would like to check. Let's check my local database, which is called Query Store Key Store Demo. It's asking for my authentication. Yeah. It keeps asking these details because I'm running DMVs, so they are more sensitive. Power BI notes how sensitive they are, so it keeps asking these questions. And here it's showing the information. Of course, I don't have much activity. I just create the database, but it's showing that my weighted statistics are focused on network I/O. Yes, Query Store from SQL Server 2017 keeps a record of weighted statistics on the database as well. It's showing the network I/O and logical I/O reads, and topological reads on the plans that created the topological reads. The plan 2 is the one which created the top amount of logical reads. The plan 2, I use it a lot, the plan 2. Of course, this dashboard is very simple because I just created the database. And it's simple as well because you can improve this information a lot querying the query store DMVs and inserting visuals inside Power BI dashboard. So you can use Power BI to monitor your SQL Server environment, querying the query store DMVs. And this is I believe this is absolutely great. This possibility is absolutely great. The moment. So, some details about query store configuration. Um, Turning on query store. We have the operation mode for query store. The operation mode typically is read-write. This means that we will query store, and query store will write the data. If for some reason we want to keep the existing data, we can use the read only. If the data is on its maximum amount defined, it will automatically change to read only instead of read write, or we turn off the query store. Query store capture mode capture everything, define automatically what will be captured or no capture at all. It would be like the read only. Writing and collection of the data. We need to define the data flush interval. How often query store will save its data to the disk? Of course, this will affect the overhead on our server. And the statistics collection interval. How often we will collect the statistics from the query execution? Will query store summarize the statistics for execution for every minute or for every 15 minutes? The smaller is the time, uh, more precise is the result of the analysis made by query store, but bigger is the overhead that the query store could create over your production system. So needs to be careful configured. Size and cleanup, size-based cleanup mode. We can enable an automatic cleanup on our query store reaches a specific size of the data which it is storing. Stale query threshold days. What it means? If a query is not executed for a certain amount of days, should that query be removed from query store? Should that be cleaned up from query store? And what's the max size of data that query store can capture and hold? All these are important configurations to manage the query store performance. So let's say a magic tool like query store doesn't take the DBA job. There are a lot of DBAs that keep this concern. Oh, this tool will take my job or something like that. No, not at all. Not at all. Uh, so Query Store will be just changing the job of the DBA. The DBA will need to focus in different points of configuration. And again, I'm talking about a technology that was created in SQL 2016. On the following sessions, you see how this technology advanced up to today to SQL Server 2022. And here you see on the database properties the configurations that I mentioned. Operation mode, data flush interval, statics collection interval, max size, and so on. All these configurations that I mentioned here. Example about setting these configurations. Alter database, set query store on, and then specify the configurations. Operation mode, cleanup policy. Many of the configurations that I mentioned are part of the cleanup policy. Then data flush interval, max storage size, and interval length in minutes. So, some ways to manually control the information: flushing data to disk, SP query store flush DB, to flush the data in memory to disk, and cleaning query store. You can completely clear what's inside query store using alter database current. This is a feature to affect the current database. Current is really a keyword to affect the current database. Set query store clear. In 2016, this was not a big deal. You were losing some history, but these were not a big deal. But you will see on further sessions how query store became very important for the new features, and clearing query store became really a big deal. Query store really became a big deal. Query store behavior: shutdown of the server. When the server is shut down, query store saves the data. Or you can use a shutdown with no wait, and query store would lose data in this case. There is a trace flag 7745 that changes the behavior. If query store will first save the data during the shutdown, or if it will always be making a shutdown with no wait and lose the data in memory. On the start of the server, the query store tables are started synchronously. So the query store tables can need to get up and running before the database is considered started. Again, there is a trace flag to manage this behavior, 7752, to manage this behavior about how the query store starts the process. So you have a control of the shutdown and startup process of query store. Optimize for ad hoc workloads. What are ad hoc workloads? Ad hoc workloads are queries that arrive on the server and are executed once and never executed again. So it's a good practice to enable this option in the server configuration. Why? Because if you don't enable this option, query store will be capturing queries that are ad hoc queries that will never be repeated again. And query store will be storing these queries. This is not good. Not good at all. So you need to enable this option to avoid ad hoc queries to be monitoring. In this way, you keep query store tables smaller and cleaner. And in relation to extended events, this is old. This is not up to date. But from the time that I checked it, there were 92 query store extended events to check how query store was working, how the entire process of query store was working. So we can use the extended events to monitor query store. Where we are now, query store hints, but this is a new subject that Erin will talk in a further session about query store hint. Parameter sensitive plan optimization, you have Javier talking about this new feature that is a great feature. DOP feedback. Neil Hambley will be talking about DOP feedback later today. And cardinality estimator feedback. It's also a subject that Javier will be talking. So these are new features that were evolutions from what Query-Store was when it was created in 2016. So some links again, the contacts again, I'll copy them again in the chat.